This video is for lesson 9.6. If you were gone last time when we talked about the topics in 9.5, which were dealing with what a sine function looks like and how to identify the period of a periodic function, you can come in and talk to me about it. It's not a very hard lesson to catch up on, but I didn't make a video for it. So today we're going to be using what we learned last time about the shape of a sine and cosine curve to help us graph these two functions. So last time we looked at the shape of the sine curve we used our spaghetti noodles and our unit circle to try to help us see what the shape would be, and we came up with, let's see, this shape. And as we're graphing our sine functions today, we're going to use these 5 points that I have shown to help us get a good shape for our graph. And at first it's going to seem a little crazy, I think, but once you practice a bit, it's not too difficult. You'll get really good at it, just like with all things. So these 5 points that we use in our pattern to help us get a really nice graph, they come from the intercepts of the unit circle. So, and I have a specific order here. Typically when I'm graphing, I'll start over here, then do the last one, then do the middle one, and then go up and down for the sine curve. And that order will help you get a good shape if you go in that order. And as we graph more and more of these, you'll kind of see why that order is important. But these 5 points, they come from the intercepts of the unit circle. So our first angle is 0 and our sine is 0. That corresponds to this point. The second intercept is a y-intercept. It's pi over 2 and the sine is 1. That corresponds to this point. Over here, this intercept is an angle of pi and a sine of 0. Pi 0 is right here. 3 pi over 2 is our next intercept. It's a y-intercept, and the sine value is -1, so it's down here. And then we're back to 2 pi and a value of 0. So that's where those 5 points come from in our pattern. So our sine function is going to look like this in general. So we'll have our function notation, and then we'll possibly have a number in front of the sine, like 2 sine x or something. We possibly will have a number here in front of our x minus h grouping, and we could have a constant being added to our function, usually at the end. So today we're really just going to focus on the a over here and the k over here. And you've done a lot of transformations with other types of functions, so you may recognize what the a and the k do, but both a and k are dealing with a vertical change in our functions. So we're going to focus on the vertical changes today, and then next time we'll focus on the horizontal changes. So the first one, like with all other functions, if you have a constant added to the end of your function, like the little k I have in the circle there, that is going to translate your function up and down. So right here in the blue, you can see the function f of x is equal to the sine of x, and below that in red is shown the function f of x equals the sine of x plus 2. So when we're looking at vertical translations, you really want to focus in on what's called the midline, and in both of those graphs that midline is shown in green. So the midline, you'll notice that in both cases the function does go above that midline and it goes below that midline, and that's why it's called the midline, because it's literally the middle of the function. vertically speaking. So when you have a constant added at the end, it's just going to shift that midline up or down, depending on if k is positive or negative. So we want to focus on that midline, and then we can draw our curve going above and below that midline. So the first one that we're going to graph is the sine of x plus 4. So we didn't talk about that yet, sorry. So if we want to graph the sine of x plus 4, we're adding the constant 4 to the function. So what that means is that the function is shifting up 4. Our midline is now going to be up here. That's going to be the middle of the function. Now last time we talked about, and hopefully you remember, but if not, you'll remember soon enough. Last time we talked about what the period of the sine function is, and in radians we said that the period was 2 pi, and in degrees the period of the sine function is, or at least the basic sine function is 360 degrees. So what that means is our sine function is going to have one cycle happen between 0 and 360 degrees. So we're going to use our pattern to help us graph this. So remember our pattern from the other page was that if we have our midline, the sine starts and ends on its midline, halfway in between it's on its midline, and then halfway in between these two it's going to go up, halfway in between the last two that's going to go down. So that's our 5 pattern. It's hard when you can't see me pointing. Okay, so our sine function is going to start here on its midline on the y-axis. And then we're going to go to the end of its period over here at 360. It's also going to be right on its midline. We're going to cut that in half, so halfway in between that 0 and 360 is a 180. So we have our first 3 points of our pattern, and now we're going to go up 1 to that little maximum there, and then halfway in between these other two it's going to go down 1. Now those 5 points just give us a 1 cycle, but we know this is a periodic function that repeats itself, so we should try to continue that pattern. So it's like middle up, middle down, middle up, middle down, middle, and it would continue that pattern. And then once you have your pattern continued with those dots to help you, you can sketch it. Sometimes people want to draw these jagged with, you know, sharp peaks. Do try to make them curvy. The domain, which we talked about last time for this function, is all real numbers. You can use that real number symbol, or you can write from negative infinity to positive infinity. And for this function, and for all functions, remember that the range is the lowest value, the minimum value, up to the maximum or highest value, bottoms up. So the range here is from 3 is the lowest value up to the number 5. And also remember that we use square brackets there because we do include those two values. The function has a value of 3 right here at 270 degrees. It has a value of 5 right here at 450 degrees, and also in other places. Okay, we already talked about the vertical shifts. Okay, let's try one more of these. This one's back in radians. So the sine of x minus 3. So if we want to subtract 3 from the function sine of x, this is going to shift our function down 3. So our midline is now going to be here at negative 3. Remember we talked about that the period here is 2 pi. So it's a sine function. Our pattern we know is going to start on its midline, and at the end of its period over here at 2 pi, it's going to end. That cycle is going to end on the midline. Halfway in between, it's going to be on the midline as well. And then halfway in between those first 2 points, it's going to go up. Halfway in between the second 2 points, it's going to dip down, just one. And we can repeat that pattern. And it will go up, middle, down, middle, up. Sometimes it's a good idea to just kind of stop right now and look at those points that you've sketched in and see if it looks nice and symmetric, and you'll start to get a better eye for it as you go along. And then you could sketch in your function. Okay, we know that the domain of these is all real numbers. The range in this case, the lowest value is -4 up to a high value of -2. And we shifted it down 3. Okay, so if you have a constant added to the function, it's going to shift it up and down. What if there is a number, a coefficient, that's being multiplied by that sine function? Well, in this case, the blue graph here shows the sine of x. If I multiplied that by 2, we are talking about a stretch here. It stretches it. It makes each peak twice as high and each valley twice as low. So we're stretching it by a factor of 2. We have a name for that distance. It's called the amplitude. So this particular graph shows 3 times the sine of x. You can see I have the midline there at 0. And the amplitude is this distance to the peak. That distance should be the same in each case for each peak and each valley. It should have that same distance. Now, if that number a is negative, we don't say the amplitude is negative. Amplitude is always going to be a positive number. You'll notice that on some of these, it's going below by 3. The amplitude is just that distance. It's not considered a positive or negative number. Just it's the absolute value of that a. So let's sketch a couple of these. So the first one is 2 times the sine of x. You've already seen it, but let's figure out how to draw the graph of it. So in this case, 2 times the sine of x is going to be a function with an amplitude of 2. And we've talked about that the period of this sine function is 2 pi. So we have a sine function with an amplitude of 2. Now, on these first couple that we're doing here, I am not adjusting the midline. So we have our midline at 0. It's not going to be shifted up or down. Okay, so it's a sine function. We know our pattern, beginning and middle, up, down, with the midline right here. So we're starting on the midline and ending on the midline, starting and ending one cycle. Halfway in between those two, it's going to be on its midline as well. And now, instead of just going up 1 like I have been doing on the other ones in the past, I go up 2 above the midline, and then I dip down 2 below the midline. That's my amplitude of 2. And so now I have those 5 points in for that part of the pattern. I can extend that to other cycles. It's going middle up, middle down, middle up, middle down, middle up. And make sure you keep the spacing the same as you're going along. Ooh, that's not a very good one. So here's our function 2 times the sine of x. The domain of this function, like all of our sine functions, is all real numbers. And this time our range is from our lowest value is -2 up to our highest value of 2. All right, let's try one with a negative. -3 times the sine of x. So our amplitude in this case is 3. It is not -3. The negative is not included. It's just an amplitude of 3. Our period is going to be 2 pi. So in this case, remember I didn't change the midline of this one, so our midline is at 0. And if we do our pattern, it begins and ends right on its midline. halfway in between, it's also on its midline. And now we use the amplitude to get those curves. So in this case, our amplitude is 3. Now what that negative is telling me with the sine curve is instead of going up 3 right here, I'm going to actually dip down 3. It's essentially reflecting it. So I'm going to go down 3 here. I'll get rid of that. And then between these other 2 points, that's when it's going to go up. So we've got midline down, midline up, midline down, midline up, back to the midline, and we can sketch that in. The domain is all real numbers, and the range in this case, lowest value is -3, up to a maximum high value of 3. Okay, so those are the two transformations that we're gonna focus on today. Here's your pun of the day. It's a stop sign. And we aren't going to work on any other transformations today, but I did want to also look at graphing the cosine function. You can see on this slide that the sine function and the cosine function are very similar. We've been graphing the sine function, that's the one in red, and we used this pattern, beginning and middle, up, down for one cycle. The cosine pattern, if you remember the cosine function, if you remember from our spaghetti activity yesterday, the cosine function looks very similar. It's just that it has a different starting point, if we want to call it that, that starting point for each cycle. And you can see they're just shifted slightly from one another. So our cosine pattern is going to not start on the midline. I'm going to sketch a midline here. So here's our midline. The cosine, if we want to think of where that cycle starts, it starts at the maximum and ends at the maximum, and in between it dips down below. And it's on its midline on those two that are cutting each half in half. So here's a cool visual of the cosine curve and the sine curve. So the sine curve is shown in red and the cosine curve is shown in blue. So they're just offset from each other. So here's the cosine pattern with these red points. Just like with the sine curve, when I'm graphing it, I like to start first and last, cut it in half again. And then once you get that pattern established, you can sketch in the curve and extend the pattern. And again, those 5 points just come from the intercepts of the unit circle. It's just this time we're talking about cosine. So it would be the angle 0 and the value 1, the angle pi over 2 and the value 0. And these are just the cosine values, so we use the x coordinates. So the transformations work exactly the same with cosine as they do in sine. If we have a k value, a constant added to the function, that's going to be a vertical shift, move it up and down. If we have a constant multiplied by the function, like the a in front of the cosine, that is going to be a vertical stretch. It's going to be affecting the amplitude. So let's try a couple of these. Vertical translation. First, we're going to sketch the graph of the cosine of x minus 3. So the minus 3 at the end, that's a constant. We're subtracting 3. That is going to shift our function down 3. So it's going to be here. And now we've got to do our cosine pattern. Remember, if you have your midline, put the cosine pattern right here. Cosine starts at its max. One cycle starts at its max, ends at its max. Halfway in between it dips down below, and then it's right on its midline. So our amplitude here is just 1. So we start 1 above the midline, and at the end of one cycle, we're also above the midline. That period is 360 degrees. In this case, we're in degree mode. Halfway in between, it's going to be dipping down below. This is kind of tricky, trickier than the sine pattern. So it's kind of making a V shape, but the curve, the function itself is very curvy. And then it's on the midline on those halves. So if we sketch it in, it's curving down, curving up, and we can extend our pattern to fill our coordinate plane. So the domain is all real numbers, and the range here would be from -4 to -2. Let's try one more of these vertical translations. So this time we're adding the constant 1, so it's shifting it up 1. So again, the cosine starts above its midline. That cycle will start here. Over at 360, it will end also at its maximum. Halfway in between for the cosine, it dips down to its minimum. Halfway in between is right on its midline. And in this case, I'm going to extend my pattern back to fill the space. So here's our function. The amplitude was 1, the period was 360. The domain is all real numbers, and the range in this case, the lowest value or minimum is at 0. The maximum is at 2. And we shifted it up 1 unit. Okay, so that's vertical translations with the cosine function. Let's try some vertical stretches, changing the amplitude. So the first one we're going to sketch is 3 times the cosine of x. So this one does not have a vertical translation, so we're going to sketch in our midline here at 0. Sometimes people don't like to sketch in these midlines, but I would really encourage you to, because most of the time you get a nicer graph if you kind of help give yourself that visual. Okay, so the amplitude here is going to be 3. It's right there on the function. And our period is going to be 2 pi. So again, the cosine pattern tells me that the function begins and ends its cycle above the midline, dips down below, halfway, halfway. So in this case, my function cycle is going to start 3 above the midline, and at the end of its end of one cycle, it's going to be 3 above the midline. Halfway in between, so at pi, it's going to dip down 3 below, and then halfway in between each of those sets, it's going to be right on its midline. So here's my 5-point pattern, and we can extend that. Let's make sure we get the spacing right. Dip it down, up, and now we can sketch it in. Not my prettiest curve ever, but that's okay. All right, so the domain is all real numbers, and the range in this case bottoms up from -3 to 3. And one more of these, we have negative cosine of x. So our amplitude here would be, that coefficient. Its amplitude is 1, not -1. Be careful there. Remember, the negative is just telling me that the function is reflected. So the amplitude itself is 1. The period is still going to be 2 pi. So as we graph the cosine, let's sketch in our midline here at 0 to help us be reminded where the middle is. it normally, as a cosine with an amplitude of 1, it would normally start here above the midline, but because of that negative, it's going to flip it down and reflect it to 1 below the midline to start. It's got to end where it starts, so it's going to be also below the midline here. Halfway in between at the value pi, it's going to be above the midline, and then in between it's going to be right on the midline. So our whole pattern got reflected. So it's more of like an upside down V. Guess I can't do my midline in the same color. Sort of hides the pattern. Okay, so we've got that portion of it. Erase that. And we can extend the pattern over to get the rest of that shape. Domain is all real numbers and the range is from -1 to 1. Okay, so now we're just going to graph a couple of functions that have both translations happening. So this first one, j of x is 15 times the cosine of x minus 5. Now the order I have these listed in is, I think, a good order to think about these things in. So the first thing that you can think about is, where is your midline? Well, in this case, the function is shifted down 5, so my midline would be down here at -5. Watch the scale. This coordinate plane, or at least the y-axis, is scaled by 5s. So I know my midline is down, has shifted down 5. This is a cosine function, so my pattern is going to be maximum, maximum, minimum, on, like this. And so I need to use the amplitude now to help me figure out where to have that cycle start. And the amplitude here is 15. That means I want my cosine function to have its this one cycle start 15 above. So here's 5, 10, 15 above. It's not starting at the value 15, it's starting 15 above the midline. And then down here at 2 pi, at the end of the one cycle, it's going to also be at that same value. Halfway in between, at the value pi, it's going to dip 15 below. 1, or 5, 10, 15 would put me here. It's not at -15, it's at 15 below the midline. And then halfway in between, it's going to be right on its midline. So here's my pattern, and I can extend it to include the rest of the coordinate plane here. And then we can sketch it in. Be careful on your ends not to show them continuing up. That's a common error. It does turn around and keep oscillating back and forth. It doesn't start going up high. So the period here was 2 pi. The domain is all real numbers, and the range in this case bottoms up from -20 up to the highest value is 10. Okay, g of x, 1 minus 2 times the sine of x. So it's not uncommon to see a function, a trig function, written this way. It's sort of backwards from what you're used to seeing. So our constant value came first. Usually we maybe see that as a +1 at the end of the function. And the multiplier of the function, the constant in front of the sign of the x, is the -2. So it's really maybe better to think about it as a -2 sine x plus 1. So, or at least if you want it to be in the same form as the other ones we've graphed. So our midline shifted up 1. Our midline is y equals 1. So that will be here. And this time we're graphing a sine function, so we're switching back to our other pattern. The sine pattern starts and ends on its midline. Halfway in between, it's on its midline, and then it does its max and its min. So it's kind of this other shape. So I can start putting my first point in right now because it's right on the midline. And at the end of that one cycle at 2 pi, it'll also be on its midline. Halfway in between, it's on its midline. And now finally I'll use the amplitude. I use the amplitude a little bit sooner when I'm doing the cosine, but with the sine you can get those 3 points on your midline first. This is a -2 here, so the amplitude is 2. The negative tells me go down first, then up. So I've got my points and I can extend my pattern. And we can see that it looks like this. Domain is all real numbers. The range is from -1 to 3. Okay, one more to graph. This one also looks a bit strange, maybe. Negative cosine of x plus 6 is all being divided by 2. Well, in this case, if we want to put it in the same form as the others, we want to divide that 2 into both parts, or divide both parts by that 2. So we could write it as, and this is the same as like a -1 cosine x, so we could write this as a -1/2 cosine x. And then we also need to divide that 6 by the 2. So that would give us the value 3. So again, I'm just kind of dividing both parts of that numerator by 2. So now that it's in this form, you can probably recognize that our function is shifted up 3. So we have a midline up at the value 3. Our period, this one looks like it's in degrees, so 360 degrees is our period. And our function is a cosine. So if we've got our midline, remember the cosine pattern is not starting on its midline. So I need to use the amplitude right away. So the amplitude of this function is 1/2. The negative tells me start below, end below. So we are starting at our min. And then halfway in between, it's going to go above. So we're kind of flipping this pattern over. And then it will be on its midline. So now we have our 5 points. You can see it's kind of making that upside down V shape. So you can pause and look at it, make sure you're getting the shape that you want. And you can continue the pattern. Oops, that should be on the midline. And then we're ready to sketch the graph in. This one's very, I guess we could maybe say shallow. Okay, so there it is. The domain is all real numbers. For the range, I think it would be fine if we wrote this as decimal form. So the range would be, the lowest value would be 2.5, and that would go up to a value of 3.5. We won't be really spending a lot of time or graphing a lot of tangents this year, but I did want to show you what they look like since we're focusing on sine and cosine. A tangent function looks something like this. It's quite a bit different from sine and cosine function. Um, Remember that the tangent we talked about with our unit circle is the sine divided by the cosine, or the y value divided by the x value. So because of that, because it's a quotient, every time you divide by 0, it's creating, or I guess try to divide by 0, it's creating these asymptotes in the graph, which here are shown as those blue dashed lines. So the function itself is the orange function, the orange shape, and the blue dashed lines are asymptotes. You may recognize this. There was actually a graph like this on your last homework assignment that it was asking you if it's periodic or not. And a lot of you ask me, can it be periodic if it is not connected? And it can be. The tangent is a periodic function. It's fine for it to have those types of asymptotes. And then here's a graph that shows all 3 functions together, the sine, the cosine, and the tangent. Isn't it pretty? So the tangent is shown in green. Okay, oh, second pun of the day. My tan lines are showing. It's so funny. Okay, last thing. Can you write an equation from the graph? So if you can see the graph of the function, can you work backwards and tell me what that function was? So this first one we're going to work on is the blue one, and then we'll try the red one. If you're writing the equation of a trig function, the first thing you need to do, please do this, is sketch in the midline. Find that midline. Now, a lot of times, not a lot of times, but sometimes people will not eyeball the center right. So this is why I like you to sketch it, because usually if you sketch it in the wrong place, you can catch your error, because you can see, oh wait, this is going up 4, whoa, sorry. This one's going up 4 and this one's going down 2, so I didn't identify the right middle. It's not the right midline, and so sketch that midline, because when you're eyeballing it, sometimes you can make an error, but if you've sketched it, you'll often be able to catch your own error. So here's my midline. So you can see that the function shifted down 1 unit. Well, on our equation, let's see, we'll start it with a y equals, or you could use an f of x equals or something. We know that shifting it down 1 means that we're going to subtract 1. So now let's think about if this is a sine or a cosine. Well, I like to think about where it crosses the y-axis. So it looks like it crosses the y-axis here, and the function is right on the midline on the y-axis. And I can identify also the end of one cycle, and it looks like when I sort of start trying to find some of those points that make the pattern, this very much looks to me like a sine function. And we'll talk a little bit more next time about the differences and the similarities between sines and cosines. But for now, I would identify that and hope you identify that as a sine function. So the last thing that we need to think about for today at least is what the amplitude is. And the amplitude, remember, is telling you that distance between the midline and the mins and maxes. And in this case, that amplitude is 3. So we would say that this function, or we could write this function as 3 times the sine of x minus 1. Okay, one more. We have this function that's shown in red. So again, you should start by finding where that midline is located. In this case, now that you have that midline sketched in, you can see that the function shifted up 4 units. So we know we're going to have a plus 4 at the end. And if we look at our pattern to decide if it's a sine or a cosine, it looks like it crosses the y-axis here. Its intercept is at 2. And here's the end of the cycle. Here's the halfway and the halfway and the halfway. And so when you see those 5 points in that pattern for one cycle, you can hopefully identify that as a cosine. And then we finally want to think about the amplitude. Well, it looks like its amplitude is 2. You can see it's going 2 above, 2 below, 2 above, 2 below. And in particular, it starts below the midline. So we would say that that's a -2. And I'm going to rewrite it since I kind of scrunched it. -2 cosine x plus 4 would be the way to write this function. Okay, so that's it. The homework is in your notes packet and it is orange. Let me know if you need any help. Thanks.